5 steps here. So we know what we're doing at every step. System, future system. Draw free-body diagram. Then write the units. Solve them. And finally, verify the results if you can. So, to answer the first step, which one should I choose as system? Obviously, it's simple. We only have one part. So what I'm gonna do, I'm gonna choose this guy. This slab concrete slab is my system. So system 1, right? So don't forget to check mark every step you go. Check mark. Now that's the system. Next step. Draw free body diagram. So in order to draw it freely, I just make it simplified, as simple as I can get. Don't need to do detailed. Don't need to do detailed drawing. There you go. And then, in order to draw a 3D, what do I do? 2 steps. Water on it to get surface work, and then if you add gravity to the body. Now let's pick this point and start walking all around this to get body force. The first thing I caught here is the 15K force. Do I have it? Yes. So I just put 15K. If I don't have it, I introduce a variable unknown. Now continue walking. The second thing you caught from the surrounding is the cable, right? So the tension in cable, do I have it? No. So let's call it TD, unknown. Introduce a variable. The next thing is TA. And then continue walking around it. And then the last thing is TC. Since I don't have this variable, I introduce the new one, TC. Right? You come back, then you come back to the start point. So you're done with body force. Surface force. Now you go to body force. Do I have body force here? Yes. So look at the mass. Yes, significant mass. This is like 2.5 metric tons. So it's very heavy, right? So you have 2,400 kilogram mg times 981 in newtons. This is the force. But the question is, where should I put it? In the middle, because this is a uniform slab, right? Sometimes they may trick you and say, well, this is non-uniform and its center of gravity is here. So you put it at center of gravity. But because this is uniform, the center of gravity is the center of geometric center, which is here, right? So all you do, you put this value at the center of this object, it's here. And it's, let's put it in the calculator, I forgot this thing.
It's 23,524.
Let me double check, thanks. Let me double check.
Yeah, believe me. No, a lot of them before.
It's actually 23,000. So it's 23.5 K. Right? 23.
That's what I said.
Oh, you said 23. I thought it was 22. I said, yeah, I'm sorry. Yeah. So it's actually the value. The point is come to the geometry center, which is the center of gravity. Because it's uniform, right? Now I'm done with the body force, so I'm done with the FPD. Don't forget to put your check mark here. Always try to have a little checklist in your scratch paper to check mark it. Make sure that you know what the step you're at, right? Because you can easily get lost during this complicated procedure. So then you go to the next step, which is writing the equations. Now, before we get our hand dirty in writing equation and solving, I do feasibility study, that if I can solve it or not, right? Now I ask the question, can I solve this problem or not?
Yes.
Yes, why? Because the number of unknowns, how many unknowns do I have? 1, 2, 3. How many equations do I have? 6, because it's
3D.
three-dimensional, right? 3 is in 3, right? So yes, I have enough equation to solve for the unknowns, right? Now with the high confidence, I go to the next step. Okay? So next step is to write all the equations down. So summation of force in x, 0, summation of force in y direction, 0, summation of force in z direction, summation of moment. About the point, we will talk about point soon. So I put empty box here. With respect to x-axis 0, summation of 1. For the point y-axis 0, summation of 1. For the point z-axis 0. So these are 6 equations that you can see. Alright? Alright, so as you can see, summation of forces doesn't require a reference point. But the moment, it requires a reference point, as we talked before. So I put an empty box here because we're going to talk about it. And these are x, y, and z axes. You all know, right? All right. So if I ask you find TC, obviously this is known. This is the weight, right? The one on the right, and this is unknown. TC. If I ask you, forget about A and B, just find TC with one line, just one equation. Can you do that or not? Now, what I'm trying to get to is to talk about the reference point and how they simplify our problem. Now, what I'm asking is, if I want to only find TC with just one equation or one line, can I do it or not? And yes, how can I do it? With respect to what axis? You see, you said, let's take this reference point as A, because what are the other candidates? A, B, and C. This is not a good candidate because this is known. We try to get a point that most of our knowns are going to be. So we get rid of them and we write the equation, right? So we have 3 candidates, right? But look, if I take, he said A. If I take these 2, we get rid of somehow these 2 and then only TC show up. So I don't take C. If I want to find C as my solution. If my only interest is C, I don't take C as a reference point, either A or B. So let's say A, right? A. This is my reference point. Now, which one of those? I have 3 moment equations. The x-axis. In fact, what you do every time you choose a point, what you do, you transfer your axis to that position. So that's going to be your x, y, and z. Right? Now, if the point was B, you just move this, translate this axis and put it at B. If the reference point was C, you just translate this axis and put it at C when you write your equation. Right? Now, let's write it. Summation of moment around point A is A. Both axis X. That's exactly what you said in order to get TC with one line. Now what I'm saying is just, let's do it. Let's start with this. What's the moment coming from here? 0. 0. 15K times 0.5. Yeah, 15K times 0.5 negative. Thank you. Then go to the next one. TC.
TC times
2.5.
2.5.
TC times 2.5. Positive or negative?
Positive.
Thank you. and the weight, the moment coming from the weight. What I'm doing is just summing the moments coming from every single force, right? This is zero, this is zero. Why? Because they are going through the axis, right? The x-axis. Remember we said if they are parallel or concurrent going through the axis, we just skip it, right? Just go to the next step. What's the moment come from? The gravity force.
23.5 times 1.7
23.5 K,
times 1.25.
1.25, positive or negative?
Negative.
Negative. So, it is actually, you multiply that by this distance, right? Because the gravity is going this way. Right, so you generate a rotation like that with respect to this x-axis. See that? So what is this distance? Is the half of whatever it is. So 2.5 divided by 2, 1.25. What else? What else is contributing to the moment of region?
There isn't anything.
Huh?
That's it.
That's it. Right? So sum of moment is equal to 0. Now you can see that. One equation, one unknown. You can solve for TC. Now let's go and write all the other equations. Summation of force in the x direction. What do I get? Null equation. Perfect. 0 is equal to 0. Nothing in the x direction. But look, we still have the equation, but it's not helping us. That's the reason it's not. But it's still valid. It's not that we say, well, we don't have that. You still have this even in 2D. In fact, if you look at this problem from the side, like this, from here, this becomes a 2D, and the x-axis become your z direction in the 2-dimensional. So still you have a null equation, but it's 0, 0, not helping you. But the equation is still valid. Now you go to y. What do I get here? No. 0 is equal to 0. Z. I get TA plus TB minus 15K minus 23.5 K plus DC is equal to 0. This is positive, right? Now let's go to the moments. You already got one of the moments down. Now let's go to Y and Z. Summation of moment at point A with respect to Y is equal to, let's start with this.
0.
0
TB times 2.
TB times 2, positive or negative?
Positive. Positive. How is it negative?
Huh?
How is it negative?
Well, this is R. This is a reference point, and this is your R. R, T goes the other way,
Yeah, you're right.
right? So it's negative. Is there anyone that still don't know why it's negative? Okay, cool. So, TB times 2, negative, right? Next one, 15K times 3. What? Yeah, this one is positive. Next one, TC. TC times 4, positive or negative? Negative. Thank you. And the last one, 23.5K times 2, positive or negative?
Positive.
Is equal to 0. Summation of moment about z-axis. No, 0, right? Nothing you ask a question, well, this is my point A, and this is my axis. Which one create a rotational effect like that? Nothing. You are all going parallel to the axis. If they are parallel, you just ignore them. So 0 is equal to 0, which is another null equation. Now you
Can we go back? I know you just asked a question, but I don't understand how you got 3 for 15K times 3.
which one?
15K times 3.
Yeah, sure. So here, a summation of moment with respect to point A, and we have y-axis.
Mhm.
So summation of y moments and
Mhm.
y with respect to point A. Obviously, this is going through the y-axis,
Mhm.
right?
Mhm.
0. This one, whatever it is, times this distance. This distance is 2,
2, yeah.
right?
Mhm.
So you get that. The next one is 15K.
Oh, so you're just adding both of those
distance
distances.
from here
Okay.
to here?
Got it.
So that distance
Got
is
it.
3. Now you got it. Now you can see why we have the interesting point. We said we have 6 equations, 3 unknown, so we can solve it. But in fact, as you can see, out of these 6 equations, 3 of them are null equations, are not useful. So in fact, what I have is actual 3 equations and 3 unknowns. So I should be able to solve it. Now the question that I may give you in the exam or test or homework is like this. Let's do some numbers here. 1, 2, 3, 4, 5, 6. Now the question I may give in a test, I may just skip this two parts. Say somebody solve this problem and drive the set of equations, and these are the equation numbers. Now I want to solve. Look, the equations are given. So this is step is don't forget to check mark, right? Now I want to solve them. What is the order that I should go and solve this equation? From left to right. Well, it's, yeah.
C.
See, it's so obvious. Why? Because you know that, you already know that, well, this is the only one that has one equation, one unknown. Right? So you should have solved it for whatever the answer is. Let's say I have extra 6 equations, extra like 9 equations. A very complicated example, very complicated example, right? You know that the answer should have started with 4. Because the number 4 is the only one that has one variable, one unknown. The rest of them you can't solve it. It's 2, more than one unknown. 2 variables, 1 equation, 2 variables, 1 equation, 3 variables, right? So you come and look at the answer. Don't try to solve it yourself. You just come and look at the answer in multiple choice. Then you see this is the only one that is solved for. So you just select this and go to the next question. Save your time. Because look, in more complicated examples, I may have more steps, right? You don't need to read all of the steps. Just say the one that started 4. Now let's do it. If you solve 4, what you get is, let's use blue. You get this, right? You get TC. And then what is the next step? 5, right? Then you put it here. So we already have this, right? And you get, out of this equation is TB, right? And then the next step. You put TB here. And then you put TC here, you get TA out of this equation. So you solve for all ABC. The problem solved. Now let's say you get an answer like that. Let's say you put these numbers in the calculator, and since you don't have enough time, you just do it very quickly, and then you get these values. TA is 12K. For example, these are not the actual solution to this problem. Solve it at home. Well, let's say you get TA 12K, TV negative 1K, TC is 22K, and this is negative. Let's say this is negative 2K. Right? Let's say you just get this. Now the question is, last step, verify. So we already solved it, check mark it, solve, and then verify. Why verify? So I'm talking about this. How do you verify it? Which one is terribly wrong? What is the sign of there is something terribly wrong?
B.
TB is negative. Look, these are not columns, these are tables. The force table is always tension. So if you take tension as a positive, the answer should be always positive. But I get negative here. So what I understand is I am doing something wrong in the calculations, or in the equations, or in the free body diagram. I don't know. So what you do, you just reiterate. You just come here and do reiterate. You go back and check everything. Go back and check everything. You see what is missing here, right? All right. So now let's go to the So far, what we have discussed was the polished, the smooth surface. So in a contact point, right, like in rollers or in something sliding on the surface, or everything that we discussed so far was frictionless, the smooth frictionless, right? Now we want to study the effect of friction. So in order to study the effect of friction, you have to have a microscopic view of the problem. So in the contact point here, if I have the tool that I can zoom it out like 100 times, 100x zoom, right? Then what I see here, this contact surface between the earth and the object is a surface. You see little bumps here, right? And then this is the object. Mass M. You have very small roughness at this contact surface. Very small roughness. It's not smooth. If you have a microscope and zoom on it, you have this roughness that they are engaged. So these two surfaces, objects are engaged at many points. It's not just one point. They are engaged at many points. So the moment I apply this force P, what happens? This surface is going to apply opposite force, which I show with red. So from the surface to the object M, there is an opposite force dr1 at this point. And then you have another point here. dr infinitesimal opposite force at point 2. And then another point. In fact, you have infinite points. this roughness is, you have infinite contact points. Each one of those has a small resistance force, which is this way. So it has a normal component and has a frictional component in the x direction, right? So if I decompose that, each one of those, if I decompose it, I get the dF, the frictional force, which is opposite to the direction of motion. This is the point. The friction force is opposite to the possible direction of motion. It's not probably, it's not moving, it's about to move, but it's not moving. But the possible direction of motion is that way, right? The friction force is always opposite to that. And then there is a normal component, dm1. Same here, for this guy, you have df, this is 3, right? df3, dm3, because that's the resistance force number 3, right? So in fact, you can say sum of all this infinitesimal friction, df, df1 plus df2 plus df3, so on to df infinite, sum of those is a friction force that is acting this way. F is just sum of all dfi, infinitesimal friction force, right? And the sum of these normal forces is also n, the sum of dni. Normal. But look, this friction force at this point, as you can see on this picture, here you have more friction, right? Here you have a lot of friction, and then here you have a small friction. In fact, it's a distributed load. The value of friction on the surface at each point is a distributed load. It's very small here, and it's almost maximum somewhere here, right? Because they already start to tip over, right? So here we have more friction than here, right? So in fact, if I want to take the resultant, sum in the x and y direction, and say F and R, where should I put this resultant?
1/3. That's the
Yeah, if this was a triangle, yes, 1/3. But let's say this is a complicated surface. I don't know where to put it, but I know that there is a geometric center here, right? But I don't know it because the pattern is very complicated. You can estimate it with triangle, but that's not always valid. It's not known. So I say at a location that I don't know, like this, with respect to, let's say, center, this x. This x, I don't know. So I have one unknown in the system. So when I count the number of unknowns, that location is also unknown, should be counted, because I don't know it, right? Then I put this resultant at that location, x. So let's do it. And F. So that's what you get. For every friction force, you get 3 unknowns. A location that we don't know, a component opposite to direction, call it F, a component normal to the direction of moment, the direction of motion, which we call it N. So we get 3 per friction force in the system. So if I have 3 force order objects, every one of them, they get different friction, F, N, and X, different, right? One more thing that I want to say, in order to find the relation between F and N, right? We can say F, the friction force, is proportional to the normal force. Why? Just through experiment. Let's say this is 1 kilogram, and I put it on a flat surface, and there is some friction, right? And I apply force P to move it. I don't really need that much of force to move it, because it's just 1 kilogram, for example, right? But if the normal force, instead of 1 kilogram, the weight, if it was like 2,000 kilograms, then I would need a bigger friction force to move it. So friction is proportional to F. This comes from the experiment. And this constant of proportion, if we convert this proportion to the equation, we get the constant of proportionality, we call it mu, times N. That's what we get, right? So you have a equation like that. So every time that you add equation, you add a friction to your system, you bring more unknown, more confusion, but also you have more equation. You add this equation to the system, right? So still nothing is new. Nothing is new. We just have one extra equation when we have friction. So how do you use this equation? Well, this constant is given in a table. It's in either appendix of your book or in the test I give it to you, right? Or if you go and design a system in industry, there are handbooks, engineering, mechanical handbooks, civil engineering handbooks. These are all given in the handbooks. So there is a table that lists if you have wood, right, then mu is this. If you have steel surface, then mu is this. If you have the concrete, mu is this. If it's polished, mu is this. It's a very detailed table. But what I'm saying is this is always known. This is always known. So you actually get one relation between the simple relation between the normal force and the friction force, right? All right, so the last thing I want to say in the friction, if you do another experiment, if you measure the value of friction versus P. So let's say we go to lab and we have a sensor that measures the value of P and another sensor measures the friction. So when I don't have force, when P is 0, what's my friction? 0, right? When I increase P, what happens to the friction? The moment I increase P, right, the friction is going to go up with a complicated pattern. With a complicated pattern. And then it reaches to a maximum. Then what happens?
It starts to drop.
Start sliding, right? Start sliding. As long as this height is not too much, because if this is too high, this is starting to tip over, right? It starts sliding. And then what happens? When you start sliding, the friction force decreases. So you have a maximum here, and then you come decrease, and then when you move a constant velocity, you are still in equilibrium if the velocity is constant. Then you get a smaller friction. So in this case, the maximum, we call it F max, maximum friction, which is Fs, static friction. And the equation for that, we call this, because this is also values, right? We call it Fs is equal to mu s times n. So in this case, this is called the coefficient of static friction. In the table, this has a different coefficient. When the object is moving, they have a different value. Now, when it moves, this value is called Fk. K means kinetic friction. And so Fk is equal to mu k times n. Coefficient of kinetic friction times normal. So the only difference is the numerical value of these two. Everything is same. You can always say F is equal to mu times n. Right? All right, so I want to give you a problem that if you can solve it, it's like a final video. You don't do final exam.